There is a change in the internal energy of the water as water changes to steam. তোমার কোশ্চেন হচ্ছে if this was happening for a evaporation case,
Yes,
uh,
sir, and not in a
then
boiling situation.
আমাদেরকে কি বলতে হবে?
স্যার সেই ক্ষেত্রে কি আমরা বলবো যে there is a change in uh, the average kinetic energy of the molecules in the water decreases, so the temperature change so the temperature decreases and internal energy decreases. এটা বলতাম।
আচ্ছা, আমি তোমার কোশ্চেনটার কয়েকটা অ্যাসপেক্ট বলতেছি। ফার্স্ট অফ অল, there are a couple of things that you need to distinguish very clearly. Usually whenever these kind of questions are done with this exact set of words, let's say if we consider this exact situation only for if the scenario was room temperature evaporation, we have to understand that we this question word by word would mean that you are to compare the change of internal energy for the gas molecules themselves as they turn from liquid into gaseous state, not what is happening for the remaining liquid in the container.
আচ্ছা।
What happens to the energy content of the liquid molecules which became gas? For
So
the
essentially,
so in that case, they are gonna separate out further, so their potential energy will increase. We have to consider that the temperature of those gas of those vapor molecules should be exactly same as atmosphere. So K wouldn't be gained, but P would be gained.
আচ্ছা, but
And additionally, additionally, if you want to consider that, then in that case, how would we say that what is the internal energy change of the remaining liquids? That can be expressed as whenever high energetic molecules leave from the surface of the liquid to be converted into vapor state, the remaining molecules in the container has a lower average kinetic energy, so the temperature of the remaining liquid gets lowered, or they experience a decrease in their internal energy amount. That's for the scenario for the process of evaporation period. If I go further down the process and go for the complete explanation, this decrease of temperature does not happen indefinitely, because the container would be exposed to the surrounding. So whenever the temperature of the liquid drops a little bit, because of the temperature difference between the ambient and the uh, between the atmosphere and the liquid body, it starts to soak up heat from the atmosphere. So at a certain at a certain lower temperature, maybe 2 or 3 degree, depending upon how much evaporation you are having, your temperature of the liquid gets stuck at a certain point where it reaches a situation of thermal equilibrium. This thermal equilibrium does not essentially mean that it has the same temperature as the ambient. This thermal equilibrium means that the rate of heat loss by means of evaporation becomes equal to the rate of heat gain because of the temperature difference, and it's not going to become cooled any further. This is also why we say that evaporation produces cooling, which means if you put a thermometer into a liquid body that is continuously undergoing evaporation, and if you put an identical thermometer in air right beside it in air, you're gonna see that at any point of time the liquid is gonna register somewhat of a smaller temperature compared to the atmospheric air, because of that scenario, that heat is being lost, and because of the temperature got dropped, heat is gonna get in from the surrounding as well. The absorption heat is gonna be absorbed in the form of, it can be absorbed in the form of conduction from the container body into the liquid body, which can eventually get transmitted. It will get transferred across the entire liquid by convection, but the entry from the container body into the liquid is going to be conduction by means of vibration, or I can say that the glass molecules. If you see a glass beaker, the glass molecules are going to vibrate and transfer the energy to the liquid molecules first. Then those liquid molecules can physically move around. Convection can happen. That is one process, and it can also happen by means of radiation absorption.
আচ্ছা। For example, if we leave it
Yeah,
in the sun,
বুঝি নাই, বলো।
if we leave it under the sun, তখন তো infrared radiation absorb করবে।
Yeah, that's why I said that these are the two possibilities that can happen.
জি স্যার, thank you sir.
Sure, no problem.
তো স্যার যে গ্যাসটা এভাপোরেট হয়ে গেল ওটার জন্য তো ইন্টারনাল এনার্জি সেমই থাকবে, রাইট? মানে অতটুকু অ্যামাউন্টের জন্য।
না, তার internal energy বাড়বে because the liquid that converted into gas experienced volume expansion, so potential energy increased. It's gonna experience an increase in internal energy by virtue of increase of potential energy of the internal energy aspect, not the kinetic energy aspect.
But sir, is it that the high kinetic energy is getting converted to the potential energy, নাকি হচ্ছে আবার হিট অ্যাবজর্ব করে potential energy ইনক্রিজ করছে?
হ্যাঁ স্যার, এটা আমারও কোয়েশ্চেন ছিল।
If I go for the micro scale, I mean micro scale means if I try to go for assume for let's say one liquid particle which is located at the surface. I mean the average liquid particles have a pretty low energy, but because of Brownian motion, some liquid particles located on the surface can have bigger energy amount to themselves, uh, which can enable them to become gas. So for them to become gas, first they have to have that energy available in them in the form of kinetic energy that was delivered to them due to Brownian motion from the neighboring particles. Using that kinetic energy, the particle is gonna become evaporated. So the answer, Rafid, the answer to your question is the first phase, not the second one.
So using that, it's going to expand and then potential energy increase করবে, তাহলে?
Exactly. So the particles are gonna start with kinetic energy, and as they become evaporated out, that kinetic energy is gonna convert into potential energy. But
Okay, sir.
since it will be definitely converted into potential energy, I mean, sorry, where is my airplane mode? There you are. So since the kinetic energy, but still we cannot say that the temperature increases, because what I need you to understand that the idea of temperature is not applicable for a single object particle or single gas molecule or single liquid molecule. It's not applicable that way. The concept of temperature is applicable for a bulk of material. But if we could somehow, if we had some way to measure the exact temperature of a single liquid molecule or a single gas molecule, if we could, we are not supposed to, but if we could, then I could have said that. I could have said, I mean, I shouldn't say that, but no, I shouldn't say that. Should I say that? No, I shouldn't say that, because temperature is not simply applicable for a single particle. Never mind. I'm not getting there. I was starting a thought process which is not valid. That's why I'm discontinuing this thought process. রাফি, তোমার কোশ্চেন আনসার পাইছো?
Yes, sir.
স্যার,
Yes.
স্যার,
আশফিয়া বলো।
yes sir, 22A2 তে in the mark scheme it says that EP, I mean potential energy changes because separation of atoms changes. What does it mean? Can you explain?
It means in the liquid state, the particles had significant intermolecular attraction force between them. When the separation got increased in the process of boiling, the particles had to overcome the intermolecular force and get separated from each other. So since work was done against an available force, potential energy got increased.
And sir, does the potential energy increase or decrease by change?
For this case, increases because the separation got increased. So work was done against the attractive intermolecular force.
So is the internal energy directly proportional to potential energy, because both the potential energy increases and the internal energy increases in this case?
I wouldn't say it's directly proportional, because the way I always describe that directly proportional is actually a very sacred relationship between two variables. If two variables are to be related to be directly proportional, it would mean that they are gonna affect they affect each other without the involvement of any other variable, and they're gonna affect linearly with each other as well. So y equals to kx. So their power is 1 and 1, and they are gonna have proportional change. You cannot have any y-axis intercept as well. But the internal energy, the potential energy between two particles can have a lot of different sources. For example, you can have sort of gravitational force between them. You can have van der Waals attraction force between them. For ionic compounds, you can have illusory attraction force between them. So uh, I wouldn't be saying it's directly proportional. I would not. I would never prefer to use those words. But what I can say that uh, separation is reversely related to no separation is directly related, not proportional, directly related to potential energy, or I can say that, or if I use a much safer phrase of words, that would be as separation between particles increases, potential energy also increases. But I would not prefer to use directly proportional.
And sir, it also says that kinetic energy of atoms is constant. Why isn't it molecules constant?
That might have been a mistake on the examiner's part. Hold up, let me go for it. No, you can write molecules. You can write molecule or you can write particle. Both of them are equal, acceptable.
স্যার ওরা তো শুধুমাত্র ওই পার্টিকেল গুলোকে কনসিডার করছে যেগুলো ওয়াটার থেকে হচ্ছে স্টিম হয়েছে
এক মিনিট,
কিন্তু
একটু পরে বলো। Ashfa, you could write molecule or particle as well. Atomy লিখতে হবে, not essential. If you ask me, I would have definitely written in terms of molecules. I wouldn't have written atom because we're considering water, so that's a compound. I would go for molecule.
So if we write that kinetic energy of molecules is constant, then the marks will not be deducted.
No, it won't be directed. It's perfectly good. A safer word or a more generic word is particle. If you use the term particle, that can, and I mean, the beauty of using the word particle means that for applicable cases, the term particle refers to atom slash molecule slash ion, whatever is applicable for the unit observable component of that situation. So particle is a more generic word. So if you, in generally every single place, if you write that the particles of water, you are covered. Or if you write particles of let's say of helium gas, you're also covered, because particle could equivocally mean molecules or atoms, whichever is applicable in whatever places. But the answer to your question is no, marks would not be detected.
Thank you, sir.
Sure. Shubro, go ahead.
স্যার আমি বলছিলাম ওরা কেন শুধুমাত্র যে পার্টিকেল গুলো মানে ওয়াটার থেকে স্টিম হয়েছে ওগুলাকে শুধু কনসিডার করছে, ওয়ার সব পার্টিকেলকে কনসিডার করতেছে না কেন, যেগুলা কন্টেইনারে আছে প্লাস যেগুলো অ্যাটমসফিয়ারে রিলিজ হচ্ছে?
Because that's what this set of word essentially mean. Read it through.
স্যার যদি ওরা আমাদেরকে বলতো যে মানে ওভারঅল কনসিডার করতে, তাহলে কি করতে?
তাহলে আমি যে একটু আগে রায়ার কোশ্চেনের আনসার যে জিনিসগুলো বলতাম সেগুলো সবকিছু লিখতে হতো, depending on how much marks you have and depending on how much they are asking you to cover.
স্যার ওভারঅল কি তাইলে ওভারঅল চেঞ্জ কি ইনক্রিজ হইতেছে না ডিক্রিজ? বিকজ স্যার ওইখানে আপনি বললেন যে ডিক্রিজ করবে potential energy.
The total energy of the entire system is remaining unchanged. Entire system would essentially consist of the liquid particles, the glass beaker, and also the atmosphere, which is responsible for the heat exchange. The total energy of the total system that is involved in this thermal exchange would remain constant. Or in other words, I can tell you that energy is being lost by the water in terms of evaporation. When the water reaches a constant lower temperature, equal amount of energy is gained from the atmosphere as well. So delta E is equal for both of them. So the total energy of the entire system that is involved, or all the components that is involved in the system, is constant.
স্যার শুধু কন্টেইনার যদি বলে তখন আমরা বলবো যে ইনক্রিজেস টেম্পারেচার, সো প্রপোর্শনালি হচ্ছে কি
আবার বলো, যেটা বলছো, যে কথা বলছো এটা আবার একবার বলো।
টেম্পারেচারের সাথে সাথে প্রপোর্শনালি কেইও ইনক্রিজ করতেছে।
কাদের?
স্যার অফ দ্য পার্টিকলস হুইচ আর ইন দ্য কন্টেইনার।
কে ইনক্রিজ করতেছে?
কে ইনক্রিজ করবে না হিট বাড়লে, মানে হিট দিতেছে আমরা, টেম্পারেচার তো বাড়তেছে।
আমরা তো হিট দিতেছি না, হিট দিলাম কোথায়?
আচ্ছা মানে আমরা ধরে নিতেছি স্যার শুধু বয়েলিং ফেজটুকুতেই আছে, if the temperature isn't changing at that point.
So sorry. I'm really sorry. I was thinking about the evaporation case. I messed up. আবার বলো. Sorry, Shubho, sorry. Rai asked me the situation for evaporation, so I was thinking about her question and I was missing it up with your question. তোমার question আরেকবার বলো. Sorry, I'm sorry.
স্যার মানে কন্টেইনারে যে পার্টিকেল গুলো আছে স্যার যেগুলো হচ্ছে ইভাপোরেট করে চলে যাচ্ছে না অ্যাটমসফিয়ারে
এখনো আছে।
সেইগুলার হ্যাঁ ওগুলার তো স্যার কেই বাড়তেছে না
না ওগুলো কেই বাড়তেছে না because as long as the boiling process is ongoing, we have to consider the entire water and all the container. They are all kept at the limiting value of the transition temperature, that is 100 degrees Celsius. As long as the boiling process is not finished, everything would be maintained at 100 degrees Celsius. Not all, uh, average temperature, I mean temperature of the entire container, water and the container would be 100 degrees Celsius. So average kinetic energy of the liquid molecules are remaining the same.
আচ্ছা মানে যেগুলো জাস্ট হচ্ছে স্যার এসকেপ করতেছে অ্যাটমসফিয়ারে ওইগুলাই হচ্ছে শুধুমাত্র চেঞ্জ হচ্ছে ইন্টারনাল
না, for boiling case যেগুলো atmosphere চলে যাচ্ছে সেগুলো internal energy বাড়তেছে in terms of potential energy increase, but kinetic energy is not increasing because we are assuming 100 degrees Celsius water is converting into 100 degrees Celsius of steam. Only for the exclusive case of boiling, not cooling, not heating. The question is limiting its discussion volume for the exclusive incident of boiling, which means boiling happening at the boiling temperature. State change.
ইয়েস স্যার
বুঝা গেছে? Sure.
স্যার বিটা
হ্যাঁ বলো কোন পার্টটা বুঝে নাই বিয়ের? I read the question.
স্যার বিটাতে ঠিক কি লিখবো এটা মার্কস স্কিমে মানে লেখা নাই আর আমি নিজেও বুঝতেছি না জাস্ট ইকুয়েশনটা লেট দেওয়া আছে যে del u equals to w plus q
এক্সারসাইজ পড়ছো?
স্যার পড়ছি কিন্তু মানে ক্লিয়ার না
Sir, why is it equal to del Q?
The work done yeah, so some warmer water down into gaseous state, molecule will be definitely larger compared to the, this is because the temperature is same. However, and work had to be done or energy had to be provided to give them the increased separation comma working against the intermolecular force had to be provided to the particles which converted into gaseous state. So now they will have increased P but not increased K because temperatures are same. The একটা উইন্ডো বের করলে আরেকটা উইন্ডো হারায় যায় altogether. The only factor we're gonna cover for your syllabus energy of the molecules and temperature. It actually does eventually whenever for the nozzle of the pressure valve, it does the hiss thing. Assume that this is our heat pressure. If you remember from your O levels of stuff that আচ্ছা আমাদের pressure volume আর pressure কথা হলো পরে আসতেছে. So let's have a look over here. For example number 3, or is it covered over here? কোনটা দেখি
স্যার একটা কোশ্চেন ছিল
একটা কোশ্চেন একটু পরে করো, ওয়েট করো, একটু হাত উঠাও, আমি দেখতেছি। আচ্ছা, I don't see it here, so I might as well help you remember about the pressure thing that I was trying to tell you, and that is that হ্যাঁ তোমাদের এটা কেমিস্ট্রিতেও আছে, so অল্প একটু করে আছে so pressure পার্টটা হচ্ছে এরকম যে for a fixed amount of gas that we are working with for a fixed amount of gas so now whenever I say this I'm considering the pressure is already a constant so for a fixed amount of gas pressure
Yes, sir.
in gas is expressed by the phrase the rate particles are going to have random as collision on per second multiplied by the similar to this idea but not essentially same that a small force in the scholarship with along with the along energy
because constantly evaporate করে চলে যাচ্ছে না
তুমি কি example
Yes, sir. Thank you.
back to you the moment some water particle has converted I'm using the term water do some physical work in the forces of the water the energy transfer happens by means
Yes, sir. Thank you.
no problem শুভ্র তোমার কোশ্চেন পরে নিচ্ছে আবার কারেন্টলি ডিসকাশন করে নেই I'll get back to you let's have a look at example number 3 whenever some water is heated to boil during the boiling process the temperature does not change but we need to provide heat energy continuous to maintain boiling this applied or absorbed heat energy goes into two places have a look part of the heat energy is used to overcome the intermolecular attraction forces of the water molecules and to make them free of each other which is basically the gaseous state so you are going to spend some energy to strip apart the molecules water liquid molecules from each other to overcome the intermolecular force altogether and then to occupy the volume for itself the steam molecules have to push the atmosphere particles and do some physical work in the process part of the energy goes up to do this work now let me explain you should be able to understand the first bullet pretty well because that was discussed for this discussion quite a lot of time let me explain the second bullet try to think about it let's say you are applying heat to a certain amount of gas and a certain amount of liquid and you are boiling the liquid whenever boiling will happen this water molecules I'm using the term water in replacement of liquid in many cases but I'm using them replaceably or alternately so if you're heating up some water to boil it at 100 degrees Celsius it's going to start to boil so whenever a certain amount of water molecule a certain amount of water has converted into gas it's definitely going to occupy a much bigger volume think about it before the water came to boil the space above the water was occupied by atmospheric molecules the moment some water particles are converted into gas and the water is actually boiling those vapor molecules will have to occupy their space in the atmosphere to make that happen it has to push out the atmospheric particles out of its path and make their own space in the atmosphere which means the atmospheric particles have to be pushed outwards to make the space available for the water molecules themselves so these water molecules will also do some work in the process of pushing out the atmosphere to make their own existent volume so that they can exist within the atmosphere this is also there so in the process of moving the atmosphere away the water molecules or the gas molecules or the vapor molecules will also do some work the amount of energy required to do this work will also should be provided from the heat source of the cooking pot so if I just give you some numerical example let's say just to give you a bit of an idea let's say you have 100 water molecules which are currently at water stage let's say a drop of water and let's say if you want to separate out all of those 100 water molecules completely from each other like you convert the entire water drop into gaseous state let's say you're going to require 1000 joule and when these water molecules are going to go up and altogether convert into gas they have to push out the atmospheric molecules to make their own volume let's say these 1000 molecules are going to require let's say 20 joule worth of energy to make this physical work onto the atmospheric particles which used to be earlier in its own space now so the total amount of energy that you have to provide to this water drop to convert into gas state is not only 100 joule. Only 100 joule will not suffice. You have to provide a total of 120 joule to convert all of these 1000 molecules, convert from liquid state into gas state, even at the same temperature. Because you have to increase the separation, you have to overcome the intermolecular force among the water molecules, and simultaneously the particles have to be provided with the required amount of energy so that they can push out the atmospheric particles and make their own volume. So that's the third example, so which was a bit detailed for the process of evaporation. These three examples are basically three examples, but there can be a বুঝা গেছে? হ্যালো,
স্যার
হ্যাঁ বুঝা গেছে। এখন কিভাবে লিখবে এটা বুঝা গেছে?
স্যার আসলে আমার নেট ছিল না, আমি বুঝতে পারছি যে 120 জুলস এর মতন দিতে হবে। প্রথমে ইকুয়েশনটা লিখবো স্যার, এরপরে আরেক মার্কের জন্য স্যার কি লিখতে হবে?
আরেক মার্কের জন্য লিখতে হবে হচ্ছে the two locations where this energy is gonna go to.
আচ্ছা স্যার, হ্যাঁ বুঝতে পারছি। থ্যাংক ইউ স্যার।
Sure. 23, 24.
স্যার 23AB।
Okay. Okay, so in which cases the internal energy of the body is increasing. So internal energy of the body can increase either by the increase of potential energy or increase of separation, or internal energy of a body can increase by the increase of temperature, or where the object's temperature goes higher. It can happen either of them, or it can happen both of them simultaneously, but both of them has to increase. Either it has to absorb heat or undergo increased molecular separation. So water freezing at constant temperature. So we're gonna have state change. So if it's supposed to freeze up, we have to take energy out of it. That's the whole idea of freezing something, that you have to extract heat out of it so that it can convert from liquid into gas into solid state. So internal energy over here should be decreasing. So not, you should not give a tick here. A stone falling under gravity in a vacuum does not change its internal energy because internal energy is not gravitational energy. Gravitational energy is an energy available to the object by the effect of something that is outside the object. So gravitational energy is available to an object because of a gravitational field. So it is not an inherent energy property of the objects itself. It is caused by a secondary object. So it is not defined as internal energy. I give you a table, send you a table for the distinguishing of the internal energy parts. Did you guys go through that table, anyone?
Yes, sir.
How many of you
Yes,
saw
sir.
that table?
Yes, sir.
2%. I know that Arnav Shah went through this because he actually,
Yes, sir.
he was the person who pushed me for this one, for that lookup. 3%. Anyone else? Good. এখন দেখো। অর্ণব ওটা কোথায় দিছিলাম তোমাকে বলো তো?
মেসেঞ্জারে দিছিলাম।
মেসেঞ্জারে তো খুঁজতেছি, মেসেঞ্জারে কই? এইটা না, এটা তো না, তো মোলের কাবজা আরো পরে না। হ্যাঁ,
হ্যাঁ আর
So shared PDF অথবা shared photos.
it was a link.
Sir, I found it.
I got it too. Everyone take a read. একটু পড়া শেষ করো, তারপর আমি নামায় দিব। Everyone go through it. আচ্ছা, gravitational energy is also potential energy. My bad, ভুল বলছি। Gravitational energy is potential energy. I was wrong. এই জিনিসটা আমার সবসময় কনফিউশন হয়, মরণ। Gravitational potential energy, elastic potential energy, electrostatic potential energy. Yeah, it's a potential energy. আচ্ছা, এটা পড়ো, দুইটা কলামই পড়ো, তারপর নামাই দিচ্ছি। 2 minutes.
স্যার এইটা না লিংক দিছিলেন আগে?
And দিছিলাম, but there are not enough people who actually read through it, but I need you to actually read through it. That's why I'm incorporating it in the class duration.
Sir, I have a question on the radiant energy.
Go ahead.
Sir, is it the photons that move? That's why we call it kinetic energy. Because for all the other examples of kinetic energy, something moves, whether it be a macroscopic body or an atom or air molecule for sound.
Yes.
For radiant energy.
Yeah, radiant energy is produced by the motion of some charge entity. Electromagnetic waves is essentially created by the movement or oscillation, to be more accurate, of some sort of charged entity. So that movement is radiated out as photons. So that would be kinetic energy. That's why.
Okay.
That's enough time to read this part. So I'm going down. বাকিটুকু পড়া শেষ করো। 1 minute.
স্যার
বলো।
ওই কোয়েশ্চেনটার অ্যানসারটা খুব সম্ভবত মার্ক স্কিমে নাই, হয়তো উঠে নাই।
আচ্ছা, ঠিক আছে, দেখতেছি, সমস্যা নেই, ডোন্ট ওয়ারি।
ওই কোয়েশ্চেনটার অ্যান্সারটা আছে, but it has like pictures of airs and a river, honestly speaking, মার্ক স্কিমে।
আচ্ছা, মার্সিম দেখতেছি আমি একটু পর। আগে এটা একটু পড়া শেষ করো, মার্সিম দেখতেছি আমি একটু পর, ডোন্ট ওয়ারি, I'll have a look at it.
তো স্যার এখানে বলেছে যে থার্মাল এনার্জি ইজ দ্য ভাইব্রেশন অফ দ্য মলিকিউলস, তাহলে তো থার্মাল এনার্জি এন্ড ইন্টারনাল এনার্জি আর লাইক ডিফারেন্ট থিংস, রাইট?
The total random kinetic energy and potential energies together make up the internal energy. Thermal energy is the internal energy, which is the kinetic energy part of the two things.
বুঝছি স্যার।
Sure.
Sir, what does motion energy mean?
Motion energy is energy stored in the movement of objects. The faster they move, the more energy is stored. It takes energy to get an object moving, and energy is released when an object slows down. We need as an example of motion energy. A dramatic example of motion is a car crash. When the car comes to a total stop and releases motion energy once in an uncontrolled instant. Okay. Motion energy would essentially mean the energy stored in an object by virtue of its motion. Kinetic energy, basically. Motion energy means kinetic energy. That kinetic energy can be conveniently converted to something else if you can extract that. For example, if you have wind energy, which the example they give, you can capture it by some propellers and you can convert that into electrical energy by rotating some turbine. Or for the example of car, if you have a car that is going at a very high speed and if it goes into a collision, in that case the collision is going to crumple the car's body and there'll be permanent deformation of the car or the passengers inside content of the car. So that in that case that kinetic energy can be converted to elastic potential energy because of permanent deformation. So the motion by virtue of the energy stored in an object by virtue of its motion.
Sir, here it is written that when you ride a bicycle, I mean in the gravitational energy, down a steep hill and pick up speed, the gravitational energy is being converted to motion energy. So
Yes.
what does that mean? I mean, in this case, what does the motion energy mean?
In this case, what it means is that when the person was atop the hill, then the energy stored within the person would be internal, that the internal energy form that would be stored within him would be potential energy, which would be gravitational potential energy. As the person would go downhill, that potential energy, considering air resistance is not taking up any segment of it, so that's the default we have to consider. Or in other words, we are consider. I mean, I'm assuming that all the GP would be converted into K, considering air resistance is not there. In that case, the potential energy that was stored within the person, as the person is going to be falling downhill, going downhill, that will be converted into kinetic energy of the same person. So you're going to have the same amount of energy stored within the person's body, but potential will decrease, kinetic will increase.
In this case, we do not consider air resistance.
For example. But if you do want to consider resistance, then you have to consider that energy transfer would not be only happening within the person's body. Energy transfer would be happening from the person's body into the atmosphere as well. So the person will be losing kinetic energy, losing potential energy. He will be getting kinetic energy, and the atmospheric particles would also get a portion of the kinetic energy because they'll be pushed out. And the kinetic energy or the motion energy of the atmospheric particles can give rise to even a little bit of heat energy, because the molecular movement is essentially what heat energies are all about. So yeah, that can also happen.
Okay, thank you.
Sure, no problem. Any other question, anyone? Energy is Ahmed Abdul Rahman, তুমি যেটা বলছো energy is released when the object slows down. That was an example that I used for the idea of crash. Or if you don't consider the idea for crash, let's say if a car actually brakes and slows down, then all of that kinetic energy has to be converted to the frictional energy in the braking system of the car and the braking force that exists between the tire and the road. So that kinetic energy has to be transferred somewhere else, so so in that process the internal energy of the car would be decreased. বুঝছো কি? Good. So let's get back to what we were saying. So a stone falling under gravity in a vacuum would be a potential energy decrease scenario. So we cannot give a tick over here either. Water evaporating at constant temperature would essentially increase the potential energy because the expansion would happen. So in this case, potential energy will increase. So internal energy should increase as well. So we should give a tick over here. stretching a wire at constant temperature. Stretching a wire at constant temperature. If you keep the constant temperature, if you maintain the constant temperature, that would mean that the kinetic
So
energy.
you're doing work
Yeah,
to
yeah, exactly. We have to do work, so internal energy will increase. Or if I go for the breakdown, that the kinetic energy of the particles would remain same because the temperature is maintained constant. But because of the stretching, the particles in between intermolecular spacing has to be increased. That's the whole idea of stretching. So intermolecular spacing to be increased. Or in other words, you can. So that's what will increase the potential energy. Or in other words, you can in a different way you can think that we have to do some permanent deformation into the work. So we have to uh, physically displace some molecules within the object from the original position to another position. That movement would require some work done. So that has to be fed from the outside. So internal energy increases as well. So there should be two ticks over here and over here. As for the Mars scheme, oh, these are weird symbols.
এগুলো কি?
These two should be
regulate
blank.
and so on.
These two should be blank, and the lower two should have a tick. It appeared as if there was an element of guesswork amongst the weaker candidates, but the more able candidates had little difficulty answering this question. Okay, just correct your Mars claims, or I mean, I don't know how to correct this on an image. Actually, I can. Acha, I might change it in the later versions. উপরের দুটা রো blank হবে, নিচের দুটা রোতে tick হবে. That's the correct response.
স্যার ওই স্টোন ফলিংটাতে ক্রস হবে বিকজ ওটা হচ্ছে যে
Cross হবে না।
আমাদের
এখানে কত cross দিতে বলা নাই। Only place a tick in the cases the energy is increasing. So you don't give a cross anywhere. You only give ticks at where in places where the energy is increasing. এখন বলো।
হ্যাঁ স্যার, তো ওই স্টোনটা ফলিং আন্ডার গ্র্যাভিটির ক্ষেত্রে কিছু হবে না, মানে ব্ল্যাঙ্ক হবে বিকজ দ্য সেপারেশন বিটুইন দ্য মলিকিউলস ইজ নট বিং চেঞ্জড। Like between the stone molecules is not being changed.
No. You're going at it in the from the wrong angle. When we're considering gravitational potential energy, the system that is constituted is not by the stone itself. Gravitational potential is existing because of the force that exists between the earth and the stone. So altogether, in this case, the total system is made up with earth and stone. You have to consider both of them together because of the existence of GP available, not the stone itself. In the process of the stone falling downwards towards the earth, the intermolecular spacing between the system's particle is decreasing because stone is getting closer to earth. So potential energy is GP is decreasing, not increasing. The question is asking us to give us a tick in the places where the internal energy will increase.
ও মানে স্যার তাহলে ইন্টারনাল এনার্জি চেঞ্জ হচ্ছে ঠিকই, কিন্তু ডিক্রিজ হচ্ছে দেখে আমরা ব্ল্যাঙ্ক দিচ্ছি।
Exactly.
আচ্ছা স্যার, থ্যাংক ইউ।
Sure, no problem.
স্যার ওয়াটার ফ্রিজিং এট কনস্ট্যান্ট টেম্পারেচার স্যার, এখানে স্যার স্পেসিংটা কি চেঞ্জ হচ্ছে না ওয়াটার মলিকুলের ভিতরে?
Well, for water it actually does change, but okay, let's say I'm gonna say yes to your question, but you please, I mean, is this your question? That is it getting changed?
Sir, the internal energy changes, right?
Well, definitely internal energy changes. It is converting from one state to another state. Yes.
Oh, acha, like it is getting balanced by the P decreasing and K increasing, I guess.
No, not at all. It is freezing means energy has to be extracted out of that liquid water to convert it into solid. So total energy is going down, not increasing. Internal energy is decreasing, hence no tick sign. One P is not converting to K, or K is not converting to P, because the whole process is happening at a constant temperature. So liquid water molecules and solid water molecules would have the same K, average K per molecule, because the temperature is kept constant. But their P would decrease because energy had to be extracted out.
Sir, stretching a wire at constant temperature would take a separation increases.
Yes.
That's why P increases.
Yes. Next question, number B dekbo. B is actually a good question, so I'll take it out to go for the detailed version of this one. Where's my MS Paint? So let's have a look at question number B, everyone. A jeweler wishes to harden a sample of pure gold by mixing it with some silver so that the mixture contains 5% of silver by weight. The jeweler melts some pure gold and then adds the correct weight of silver. The initial temperature of the silver is 27 degrees Celsius. Use the data on figure 2.2 to calculate the initial temperature of the pure gold so that the final mixture is at the melting point of pure gold. This is the information that you have to visualize properly. Try to think about it, what is happening. The jeweler is going to mix some 27 degrees Celsius silver, which is essentially solid silver, with some hot gold so that the final mixture temperature would be the melting point of gold. So the silver should have its temperature increase from the 27 degrees Celsius to the melting point of gold. So silver part would essentially absorb heat, which should dictate that the gold part should give up heat, which means the initial temperature of the gold should be higher than the melting point. First, understand this much. In this entire process, the jeweler is not going to add any more heat. We are keeping our discussion within the happening that gold was heated already. The temperature of the gold was taken to a temperature that is slightly or more, I don't know how much, that was definitely a bit higher than the melting point of the temperature. Whenever we are going to add that silver lump into the liquid gold, silver's temperature is going to increase all the way up. That is going to melt. I mean, why would silver melt? Have a look. Have a look at the melting points of the two things. What is the melting point, melting temperature for gold? 1340 degrees Celsius, 1340 Kelvin. And for silver, that is 1240. So if I go ahead to draw this in a mechanism of figure that I usually go for, let's say silver starts from from 27 degrees Celsius. This is the starting temperature for 27 degrees Celsius for silver. From here, the temperature of the silver should increase up to 1240. What is that Kelvin equivalent of this one? Can someone tell me? 273 plus 27. 300 Kelvin, right? 300 now?
300.15.
Should we go for 1.5? We actually can go for 1.5. Okay, দরকার নাই, সমস্যা নাই।
0.15 স্যার সব জায়গায় অ্যাড করে দিন।
সবখানে অ্যাড করা?
হ্যাঁ স্যার, মার্কসিমে সব জায়গায়।
তো সবখানে অ্যাড করতে হবে, সমস্যা নাই, don't worry. I might as well get to the practice of this, which I was not in.
স্যার বড় বড় ম্যাথসে 273 আছে।
আচ্ছা
মানে
সমস্যা নাই, তোমরা 300, if you're gonna go for calculation, it's always safer if you use 300.15. Your marks will never be deducted if you use 300.15. So you can make a practice habit out of it that if we are going conversion, we are gonna add 300.15. The final answer we can always give in 3SF. That's perfectly good. So let's say this is gonna be the Kelvin temperature for the starting temperature of the silver in solid state. Its temperature should increase up to 1240 Kelvin. Why up to 1240 Kelvin? Because at 1240 Kelvin, it is gonna start to melt. At this temperature, at this case, that the silver is going to melt. So I'm showing this melting process by a horizontal arrow because the temperature is not going to increase. From this point, that silver's temperature should increase even a bit further to reach up to 1340 Kelvin. This is supposed to be the final mixed temperature of the total mixture. So in this entire process, the silver piece is going to absorb heat. So essentially, the gold piece, let's say I'm going to show this with this color, should have had some higher temperature over here. We don't know how much is this. Let's say this temperature is theta or T. You can write anything because I prefer the T because for Kelvin temperature, the typical symbol is T, capital T. So let's say the liquid gold was initially at this temperature when the silver piece was added to it, and it had to come down from here to this temperature. So in this entire process, heat is going to be absorbed. In this process, heat is going to become given up. For this entire process of the black lines, solid gold melting, solid silver melting, liquid silver. For this one, liquid gold. So that's the heat exchange process. Now the additional part that we have to understand, that the question says for the hardening process to work, he's gonna add 5% of silver by weight. Keep your eyes peeled. So he's gonna add 5% of the silver by weight, which means if we assume that, I mean, out of the total, if the total mixture is 100, 5 would be silver, 95 would be gold. That's what it means by 5% of silver by weight. Because the question does not necessarily give us the individual amount of gold and silver. For the sake of convenience, we can consider it to have 95 gram, kg, kilo, ton, doesn't matter. The mass can be considered to be 95 unit, whatever that unit is. And this silver can consider to have a 5 gram or 5 kg. I mean, they both have to have the same unit, but that should be the ratio between them. Now, the question doesn't give us this number. We are coming to this number by this information. Is this manipulation understandable? Where did this 95 and 5 come from?
Yes, sir.
We're going to need this two information. Other than that, we cannot do the math, because for all the part of our math heat calculation, mass is an important factor. So I'm going to start doing the math.
Sir, আপনি 95% উপরে রাখলেন কেন?
Because this was supposed to be gold and this was supposed to be silver. Silver is supposed to be 5% of the total weight. This yellowish thing I'm trying to represent as to be gold. This black thing I'm trying to represent as silver.
But sir, initially কি 100% আচ্ছা, দুইটা যেহেতু লাস্টে অ্যাড করব, সো different.
Good. So let's try and use those variables that we have available and go ahead for the calculation. So we're going to have to use this one for the, so I'm going to write up this equation over here. So let's say 5 is the mass of silver. So I'm going to do this one first. C, the specific heat capacity of silver is 235. So 5 into 235. Wait, I'm going to bring down my write pad. I got a new write pad, which has a pretty nice color, and it's awesome.
So just send me the link where you bought it from.
This new one?
Yes, sir.
This is Huion, and it's big. I think it's 13 inch or something like that, 13 or 14 inch. I don't know. And I was lucky enough. I mean, Solsar was smart enough to order the orange-ish color for me, which is a nice color. So not exclusively black. I'm also trying to get rid of my old one Wacom. Oh, sorry. I need to connect the USB. You'll see significant improvement of my handwriting from this point onwards.
Get it out.
Yes, Rodney, what you are talking about?
Sorry, sir.
Oh, it's all right. This happens to the best of us. So 5 into 235, then how much will be the temperature difference? That should be 1240 minus 300.15. That's the MC delta theta for the silver heating in the solid state. Then I'm going to melt the silver, which is going to be 5 into latent heat of fusion of silver, which is 105 kilojoule. This was joule per kg per Kelvin. This is kilojoule per Kelvin. This is a very important observation. So this should be 5 into 105 into 10 to the power 3. Do you see my actual handwriting is popping up?
Such a relief after your MS Paint attempts, though.
It's a basic difference, nahi.
So it regularly use করেন না কেন?
I'm lazy. I have to pull it out from the box, uncover it, connect it with my.
Sir, আমরা 5 নিলাম কি
I
এর
have to
জন্য?
place all of my stuffs in proper order to make space for this whole thing on my table. That's why.
Sir, you can use
এটা
brush.
সেট করে রাখতে পারে না, মানে সেট করে রাখা যায় না টেবিলের মধ্যে?
Then I would have to go around this thing for the entire of my other time of not doing classes, and be careful that I do not scratch this surface or spill coffee or tea onto the surface or sneeze on the surface as well.
You could just
আপনি কি এক্সট্রা পেন কিনতে হইছে?
so that you don't sneeze or spill anything on the writing pad.
Come on, this is placed, for those who have seen my workstation, this is placed in front of my monitor. Then comes the keyboard, which is a very big keyboard because I got a gaming keyboard. And then comes this one. How much real estate do I have over here, do you think?
Not much.
Anyway, I'm lazy, period. And then we're gonna have to use the MC delta theta once again for the liquid silver. So since they haven't given us any different value for the specific heat capacity for the silver for liquid or solid state, we are gonna use that same exact value. If they gave us two different values, that the solid silver has one value and the liquid silver has a different value, we'll have to use two different values. But since the table doesn't give us, so the same specific capacity 235 is going to be placed over here. So 235.
5টা কি basically
And then
5%
শেষ করি
mass?
শুভ তোমার কোশ্চেন নিয়ে বলতে পারো শেষ করি I'll take a question. Just hold up a second. Hold up a minute. And then 1340 minus 1240. So this is the amount of heat that the heat silver chunk is going to absorb, which should be logically equal to the heat energy. The আমি কি ভুল করলাম এখানে?
জি স্যার, এখানে বলেছে
ভুল করি নাই।
the whole mixture is at the melting point of gold.
So my calculation is perfectly correct. So then it should be 95 multiplied by T minus 1340. Sorry, this was sorry, my bad. I need to write the specific capacity 95 multiplied by specific capacity of gold, which is how much? 129. Am I correct? Yes, correct. 129 multiplied by the delta theta for the gold, which is T minus 1340. Now this is your entire equation. You have to calculate out the value of T out of this whole equation, and that's your answer. Now start giving me questions. Shubhra, bolo.
স্যার আমরা পুরোটা সময় 5 কে কি 5% mass হিসেবে ইউজ করতেছি?
Yes.
Sir, but like স্যার এটা একটু অদ্ভুত লাগতেছে না? লাইক ম্যাচ কি দুই সাইডের থেকে ইকুয়ালি কাট অফ হয়ে যেতেছে সামথিং?
না, ম্যাচ দুই সাইড থেকে ইকুয়ালি কাট অফ হয়ে যাচ্ছে না, ম্যাচের ইউনিটগুলো দুই সাইড থেকে ইকুয়ালি কাট অফ হয়ে যাচ্ছে. So it might be 5 gram 95 gram, it could be 5 kg 95 kg.
Yeah, like ওই কারণে আমরা প্রপোর্শন অনুযায়ী নিতেছি এভাবে.
Exactly. I didn't bother to write the unit of the 5 and 95. That's the reason, because whatever the unit that is gonna give over here, that's gonna be cut off from both sides anyway. Conveniently, you can think that these are 5 kg and 95 kg because that would resonate easily in your head because these things are all given in kg, or SI unit of mass is also kg. That also works. But my point was that it doesn't have to be in kg. It just have to be proportionate so that you get the 5% to weight silver added. করে দাও কত আসে মিলছে আনসার? বলমান এখানে তোমাদেরকে একটা জিনিস বলি একটু আবিয়াজ এক মিনিট, I'll take a question. This question is not essentially difficult once you can figure out this thing. Once you can figure out this whole thing, the rest of the question is not difficult. So what I would always recommend for those who are actually starting to learn how to do this heat transfer maths, always try to draw a figure like that, or if you come up with a different version of figure that could make more sense to you, that you could get from some other books or from other YouTube videos which can make better sense to you, adopt those. If you can visualize the process well, you can write the equation smoothly without any trouble. But there is more catch to this. First catch, not being able to see this kilo. Second catch,
Yes,
messing up these numbers. Silver specific capacity জায়গায় এটা বসানো, এটার জায়গায় এটা বসানো বা এটার জায়গায় এটা বসানো, মানে these numbers could give you quite a bit of trouble if you are not careful what you are choosing in the place of which one. So the problem is not essentially difficult, it is meticulous. So another way to make sure that you score partial marks even if you are in a hurry is that other than doing this whole math in a single go, calculate up these parts individually. Calculate this and write the value. Then calculate this, write the value. Calculate this, write the value. And then you show that sum of this plus this equals to this much, and then find out the T. Divide up your working into segments, observable or markable segments, so that even if your entire calculation could be wrong because of one of the variables, you're still going to score partial marks for the individual calculations completely. So that is a safer way to go for the problem if you are not so confident in yourself. But if you know for a fact that you are absolutely confident for the math that you're putting in, you can go for a single step equation the way I did. So it's a question about how much practice you've made, and how confidently you can do this, and also how much time do you have to cover up these questions. Yes, Abias, you are about to ask a question.
Sir, sir, do we assume that the gold freezes at any point?
Gold is gonna gold. I mean, the gold is not freezing for this conversion, for the duration of the conversion that is happening. The idea is that uh, our observation is gonna finish when the temperature of the gold drops to its melting point. Beyond this point, the entire mixture is gonna start to slowly freezing up, because this is a hot object. It's gonna keep on losing heat to the atmosphere. So beyond this point, it's gonna start mixing, start freezing up, but not within this duration, because within duration, the gold is maintained above 1340, so it is in liquid state. So basically speaking, that you're gonna make an perfect alloy of both of these metals, because in the liquid state you're gonna have both of them. You can mix them up properly like a solution when they are both liquid. Have a look. For this entire duration, as the temperature of the silver is rising up from 1240 to 1340, and this one was, let's say, somewhat from here to, assuming that this was the temperature when this was happening, this was coming on here, you have both of those things in liquid state, so you can mix them up pretty well to achieve a liquid solution. Silver liquid, gold also liquid, which can give you a good alloy.
So we just the final state is when they both reach 1340 Kelvin, and after that,
bolo. Sorry, continue.
And after that, they both begin to solidify, not before that.
Not before that, exactly. They're gonna start solidify means that they're gonna solidify, and within the solidification process, the gold is gonna start producing crystal structure, and together they are gonna solidify, and eventually the temperature is gonna drop all the way down to room temperature. So that way you get a much hardened version of gold. Pure gold is actually pretty soft. You cannot make good ornaments using pure gold. If you want to make good ornaments with pure gold, those ornaments have to be extremely thick. But you can convert them into really thin, shiny ornaments if you add a little bit of impurity. That's why 22 karat gold is not optimum for ornament making. 18 karat gold is.
So first, we're just going to get a solution of silver and gold at 1340 Kelvin.
Yes.
That is just our final state, right, sir?
For this math, yes.
Okay, sir.
Sir?
Yes.
Sir, এটা কি possible না যে আপনার like silver আপনার 1340 cross করতে পারে?
Well, it's obviously possible. If you give enough heat. Why wouldn't it convert? Nothing is stopping the silver to soar for a higher temperature. But for this math, it's not going to work out, because that's how the math was designed. The question says that we are trying to figure out the initial temperature of the gold, so that the mixture's final temperature is the melting temperature of gold. Silver can get to much higher temperature, but for this math, we are not doing that.
আচ্ছা, মানে আপনি যে আগে আমাদের করেছিলেন যে 0 ডিগ্রি ধরে নিতে হবে, তারপরে ওখান থেকে we can go further. তো ওখানে that's মানে 1340 ওখানে ওইভাবে কাট.
Exactly. 1340 is exactly 1340 is our terminal point.
Yeah, terminal point. Okay, got it. Thank you.
Sure. বুঝে গেছে বলবান সবার?
Sir.
জি স্যার।
Sir.
Yes, বলো।
Sir, don't we know যে যখনই আমরা কোনো জিনিসে ইম্পিউরিটি ইন্ট্রোডিউস করি তখন তার মেল্টিং পয়েন্ট বেড়ে যায়?
That can be a chemical problem, which in this question the physics people did not bother to care about, but that's true. So the people who are actually the goldsmiths, they know about these properties, everything, and in their process they incorporate all of their parts. This is exactly why that different metal worker can produce different quality of metal. All steel are not the same steel. Some steels are much better compared to basic solid carbon steel.
So sir, basically আমরা যদি এটা রিয়ালিস্টিক সিনারিও হতো, তাহলে the melting point মানে যদি আমাদের melting point of gold আনতে হতো, we would use a higher temperature. মানে the end point of the whole calculation would be at a higher temperature, right?
For what?
যে for the gold, for the silver and gold to mix properly, we would use a higher temperature. এখানে তো 1340 তে আমরা মানে টেম্পারেচার আপাতত কনস্ট্যান্ট রেখে মিক্স করে তারপর কুল করছি, ঠিক না?
Okay.
So in more realistic cases, we temperature টা higher হবে. It will be higher than 1340, right?
I don't know for a fact. I mean, adding impurities can shift your melting point or boiling point in either direction. That depends upon, that depends upon that this new material that you're introducing into your original substance. Is it increasing your, it's about the consideration of the cohesive forces and the adhesive forces. So that plays a big role. So from that thing, it can be determined that is it going to be a higher temperature or is it going to be lower temperature. I personally do not know for a fact what's going to happen to this for this exact example scenario. It could be it could shift in either direction. That's the general information that I can tell you.
Okay, sir. Thank you, sir.
বুঝা গেছে?
জি, sir.
আচ্ছা। So let's go for our next question. So this is a suitable thermometer for the temperature, obviously thermocouple thermometer, or you can use radiation thermometer. Pyrothermometer is also okay. Do you guys know what a pyrothermometer is?
No, sir.
No, sir.
The thermometer that have been in use around the globe to measure the forehead temperature, that can measure the distance from the temperature from a distance. You go anywhere, people aim it at your forehead and they get the temperature. That's the pyrothermometer, radiation thermometer.
Oh.
So that you do not have to directly contact it. You can measure how much radiation is coming out for a specific distance, and you know what was the exact temperature of that surface.
থার্মাল ভিশন গুলোর জন্য
Thermal vision, thermal vision also works in a similar technology, but much more sophisticated, but somewhat similar.
Oh. They
24.
always digital thermometer. I mean, the one you just described. I have one at home and everyone just calls it digital thermometers. I never actually knew the real name.
No. Digital part is the expression by which it gives out the data. But what is the underlying principle by which it measures the temperature? That's radiation. You can have a thermocouple thermometer giving you a digital output. You can have a resistance thermometer giving you a digital output. You can have those thermometers that people put in their ear to measure the temperature. Have you guys ever seen that? Maybe not in person, but in some videos and everything. Those can also be digital thermometer. Digital part is the expression output. For example, Word document could be printed out in hard paper. It could be converted into PDF. It could be converted into PowerPoint. Those are the different formats. But what it is text.
Yes.
24.
So we did this yesterday.
No. Oh, yes, we did. Yeah. Oh, it's that question. Yeah, there you are. My bad. 25, 26.
স্যার 26 পারি নাই।
কিন্তু কেন?
স্যার জানি না।
আচ্ছা ঠিক আছে। 26 দেখো, the electrical resistance of a thermometer is to measure the temperature is to measure temperature in the range of 12 degrees Celsius to 24 degrees Celsius. Figure 3.1 shows the variation in temperature measured in degrees Celsius of the resistance of the thermistor. তোমাদের নেক্সট ক্লাসে আমি সাম স্মার্টার ভিডিও কালার রিলেটেড একটা ভিডিও দেখাবো, আমাকে মনে করো। There's a video that I really want you to see, which boggled my mind for weeks.
Sir, do you watch Vsauce?
I do watch Vsauce, but I'm not very fond of Vsauce channel because the concept that he covers flies far above my radar. I understand it is very amazing and it's very good. It's rich in content, but I don't like his videos because his videos give me headaches.
Headaches.
How so, sir?
Yes.
How so?
I mean, the content that he covers, most of the parts that he covers, they are really difficult for me to process, or I cannot keep my attention span long enough onto his videos.
Like
I'm not saying that his videos are bad. I'm saying my recipient processing capability is not up to the delivery quality that this person gives.
Like the
26.
banana.
So yeah, we have a graph. We are trying to measure some temperature. Then the question says, state and explain the feature in figure 3.1 which shows that the thermometer has a sensitivity that varies with temperature. Oh, well, obviously, because sensitivity of a thermometer is essentially about how much of the thermometric property change do you have for unit temperature change. So you can see that this graph over here is not linear, which means for the same temperature change, you're not going to have the same amount of resistance change for every part of the temperature region. For example, if you have a look for 12 to 14, from 12 to 14, the resistance is dropping from 2400. I mean, you can see it very well that the graph is non-linear. So it's not going to have the same amount of del resistance by del temperature for every segment, which means it has different sensitivity. It has more sensitivity where the graph is more steep. It has less sensitivity where the graph is less steep. এটাকে ভাবটাপ দিয়ে ভাষাটা সাথে লিখবা। B number, at one particular temperature the resistance of the thermistor is 2040 plus minus 20 to 20 ohm. Determine this temperature in Kelvin to an appropriate decimal places. Since they have given this thermistor temperature in with some uncertainty, it might as well be relevant for us to come up with this answer with uncertainty as well. Just because I want to make sure, I'm going to take a peek at the marks. 26. Yes. So let's go ahead and do this calculation. So I'm going to take this one. There is a much better software that comes with the Huion software, which is their default whiteboard. But I have installed it, but I haven't been using it because I don't know how to use it yet. I'm actually cool with Paint. I don't know why. I'm a lazy person. Yeah, that's why. Sorry, I'm babbling on my own.
Sorry, everyone babbles on their own. It's fine.
Hey.
Sorry, tried Microsoft Whiteboard once and never again.
I have the Microsoft Whiteboard right over here, but I might. I'm not sure. This is the whiteboard, I think.
But you're not using it because you're lazy at this right at this exact point.
Yeah, exactly. I can do my workaround. So why should I learn new technology? I'm a lazy person. Go ahead. So, I have underestimated my capabilities long enough. And one particular temperature, the resistance of the thermistor is 2040 plus minus 20 degree. So determine this temperature in Kelvin to an appropriate number of decimal places. So how can we determine this temperature to an appropriate number of decimal places? How could we do this? Acha. Okay. Okay. Kelvin বের করতে বলছে? Okay. Degree Celsius. What is 2040? Let's find out 2040 first. How much is the smallest division over this graph? Have a look here. 200 is covered in 10 divisions, so smallest division is 20 degrees Celsius. So 2000, 2020, 2040. This is 2040 mark. Goes up here, falls down to here. And we also have to consider that 2040 plus minus 20. So if I go plus 20, that would be 2060, which would be relevant for this temperature, and for 2020, which should be responsible for this temperature. So that basically represents two divisions only horizontally. So my actual reading should be here. This is my actual reading, and the variation should be plus minus this much. So that's my temperature variation. বুঝতে কি বলতেছে? Hello?
স্যার বুঝছি নাই।
This is the 2040 mark. If I go for plus minus 20, so plus 20 is over here, minus 20 is over here. For 2040, my exit temperature is this one. For plus 20, I'm gonna get this one, 20 division above. So if I thought this thing, that is, this one is 2040 plus 20, that is 2060. And it falls down all the way up to here, to this division. I mean, there is just one division horizontal spacing for every 20 degree of variation. You can see over here. So this is my actual temperature measurement point. This is the upper limit. This is the lower limit. So I just dropped all of these coordinates down. So this is my this is gonna be my actual temperature reading, which is exactly 15 degrees Celsius, and it's gonna be one division left or right. Now, how much is one division over here? For this scale, how much is one division?
2 degrees Celsius.
0.2 degrees Celsius.
Yes, 0.2 degrees Celsius.
Yes, so this is 15 and then plus minus 2. So this is gonna be 15 degrees Celsius plus minus 0.2 degrees Celsius. So now we need to convert this into Kelvin. How do you convert this into Kelvin? You add 273.15. So how much do you get? 288.15 plus minus 0.2 Kelvin. This is not going to be converted because this is the delta theta. This is the uncertainty is the amount of variation. So this doesn't become bigger anymore. This has to be changed. Now, if we go for the appropriate significant figure, appropriate number of decimal places, because this was given into 2 decimal places from the graph, so I might as well write this into 2 decimal places as well. So I would prefer to write this 288.2 plus minus 0.2 Kelvin. I hope this is a correct response.
স্যার ওটা 0.2 কেন থাকছে?
Because theta is not equals to t. Theta plus 273.15. আরে আমি কেন আমি আমার টাইপ বোর্ডে লিখতেছি না। Theta plus 273.15 equals to t, but delta theta is equal to delta t. এটা কি বুঝো?
স্যার ওটা ডেল থিটা কেন হচ্ছে ওইটা বুঝতেছি না, মানে নরমালটা বুঝছি।
Because that is the uncertainty. Uncertainty means how much variation can it have. Because 1 degree Celsius temperature increase essentially means 1 degree Celsius temperature, 1 Kelvin temperature increase. So 1 degree Celsius temperature variation would also equally mean 1 Kelvin of temperature variation. If I give you a bit of a graph interface, it might be as well be a bit more clearer.
Yes.
If you plot, let's say, the temperature, let's say, how can I write? Should I write volume, resistance, volume? Let's say this is our resistance versus temperature graph. Okay, fine, resistance temperature. So if I plot the resistance temperature for degree Celsius scale, that looks like this. So let's say this line is degree Celsius scale. So theta degree Celsius. And if you want to plot this same graph for Kelvin scale, each of the degree Celsius value is going to be 273.15 bigger. So you're just going to get another line where this thing has the exact same shape, only every y-axis value is bigger than that. So the amount of variation you're going to have along this axis is the same amount of variation over here or along this axis is going to be the same. The uncertainty on either axis is going to be affected the same way. Yes, sir.
Yes, sir.
Yeah, বলো।
এখানে আসলে স্যার মানে প্লাস মাইনাস 0.2 কি সবসময় আনসার্টেনটি হবে টেম্পারেচারের জন্য?
না,
তাহলে এই কেসে কেন হচ্ছে স্যার?
কারণ রেজিস্ট্যান্সের আনসার্টেনটি প্লাস মাইনাস 20 বলে দিয়েছে। প্লাস মাইনাস 20 ওহম এর জন্য আমাদের রিলেভেন্ট টেম্পারেচার আনসার্টেনটি 0.2 আসতেছে, গ্রাফ থেকে প্লট করে সেটা দেখতেছি।
আর স্যার 273.15 কি তাহলে ইউজ করব?
15 ইউজ করো, সমস্যা নাই, 15 ইউজ করলে প্রবলেম নাই। I mean, using 15 would not give you any wrong answer. You might have to write a little bit more, but you are definitely not going to be wrong. So it's a safer choice if I put it that way. বুঝছো?
Yes, sir. Yes.
আচ্ছা। So let's go for the next one. 27. এগুলো হাবিজাবি কোশ্চেন। এটা হাবি যে কোশ্চেন, এগুলো তোমার পারবা। 27 28 প্রবলেম কোথায় আটকাইছো বলো?
27 বিটা একটু
বলো কোথায়, কোন পার্টটা পারো নাই বলো।
স্যার এখানে এক্স্যাক্টলি কি কি লিখতে হবে বুঝতেছি না।
Do you want me to go back to my video and show you some parts?
ভিডিও স্যার।
যেখানে আমি এই জিনিসটা বুঝাইছিলাম অল টুগেদার।
আচ্ছা স্যার করেন।
I hope you said no, so that you would find it on your own. We can always calculate some work. Force to be among the water molecules, and simultaneously the particles have to be. কোন জায়গাতে আমি এই জিনিসটা পড়াইছি ওই জিনিসটা পুরোটা আবার দেখবা, দেখার পর মার্কসিমটা দেখবা, তারপর যদি এটা মেক সেন্স না করে আমার সাথে পার্সোনালি নক করে আমার, I'll help you understand it personally. I don't want to really go through the whole discussion of this derivation one more time. I really don't want to for a public class, but if you have personal problem, ask me in the messenger chat. I'll help you. 28 onwards. Twenty-eight, 29, 30.
স্যার 30C এর মার্ক স্কিমটা বুঝিনি।
Like this. B number will say two cylinders A and B are connected by a tube of negligible volume as shown in figure 2.1. Cylinder A, this many mass volume, this many Pascal, 300 Kelvin, this many centimeter cube, this many Pascal. There is a difference in pressure, yes. This one has a higher pressure, this one has a lower pressure. So whenever we open the tap, gas has to travel from here to here so that the pressure are become equal, because that's how gas behave. It travels from high pressure region to low pressure region. So you have this calculation, then we have this thing, we have found out the final temperature. What is the final temperature? What did you get as a final temperature?
স্যার 360 কেলভিন।
Acha. By reference to the work done in and change in internal energy, such why the temperature of the gas cylinder A has changed. Acha. By reference to work done and change in internal energy, suggest why the temperature of the gas cylinder A has changed. Acha. I don't know exactly what the mark scheme contains, but I'm going to use my understanding of physics to explain this question. Then I'm going to go for check the mark scheme. Try to understand the question. By reference to work done and change in internal energy, so you have to incorporate these two terms in your answer. Suggest why the temperature of the gas in cylinder A has changed. So the way I can explain this, I think, whenever the tap will be opened, gas will be transferring from cylinder B to cylinder A till both of their pressure become equal. So the previously occupied volume by the gas molecules in cylinder A would have to become decreased, because gas molecules entering from cylinder B would occupy their own volume inside the same cylinder, which means the previously occupied cylinder A gas are gonna become squashed, or their volume will be decreased by some amount, because the entire container volume is not changing. So previously all of these gas molecules were occupying the center volume, but once you open the tap, some gas from here to here is going to flow in, which means those initial gas molecules which are occupying the entire volume, they have to squash up even by a little to give the incoming molecules their own volume. So since you are squeezing the gas molecules, the particles are brought closer together, so that would mean potential energy will what? Intermolecular spacing decreases. So what happens to the potential energy?
Decreases.
Potential energy will decrease, and that decreased potential energy would convert into increase kinetic energy. So that's why your ultimate temperature of the two combined container was somewhat bigger. এটা কত 300 কত আসছে এটা 20
360
360 Kelvin. So initial temperature was 300 Kelvin. So you can see it very well that once you mix them up, their final temperature is somewhat bigger. The reason it's bigger because that potential energy that the particles are going to lose is going to be expressed as their kinetic energy.
স্যার পিই লস্ট কেন হবে? সিলিন্ডার এটা তো আরো লার্জার, আর পার্টিকেলস ইকুয়ালি স্পেসড কেন হবে না? ট্যাপ তো খুলে দিয়েছে।
ট্যাপ খুলে দেওয়ার পরে গ্যাস মুভমেন্ট কোন দিকে হবে?
বি থেকে এ।
তাহলে আগে এতে যতটুকু এর গ্যাস মলিকিউল গুলা যতটুকু ভলিউমে মুভ করতেছিল, এখন ওই সেম মলিকিউল গুলার মুভমেন্ট করার জন্য কি ততটুকু ভলিউম অ্যাভেলেবল থাকবে, নাকি ভলিউম একটু কমে যাবে?
স্যার কমে যাবে।
So that's why the cylinder A gas got compressed.
ও আচ্ছা স্যার, মানে এর যে এখন যে পার্টিকেল গুলা থাকবে ওগুলার সেপারেশন বি এর সমান হয়ে যাবে, মানে দে উইল হ্যাভ দ্য সেম সেপারেশন বাট কম্পারেটিভলি কমে যাবে।
আগের থেকে কমে যাবে।
আচ্ছা স্যার,
বুঝে গেছে?
স্যার আপনার কাইনেটিক এনার্জিটা কেন বাড়বে? Cylinder gas molecule.
Because that potential energy has to be expressed in some form, because this question does not tell us anything that heat would be lost from the sound from the containers.
মানে আপনার যে লাইক পি যেটা লস্ট হইছে ওইটাকে রিকভার করার জন্য কাইনেটিক এনার্জি বাড়তেছে।
Exactly. Recover না, মানে that would be converted into a different form of expression.
ও আচ্ছা, মানে ডিফারেন্ট ফর্মে ইয়া হয়ে যাবে, কারণ হিট গেইন হিট লস এখানে কিছু বলেন
না। হ্যাঁ, কিছু বলা নাই।
থ্যাংক ইউ
স্যার বিএ কি হবে, লাইক ইয়ে তো কমে যাবে না, নাম্বার অফ মলিকিউলস, তাহলে কি ওরা আরেকটু স্পেসড আউট হয়ে যাবে তখন?
Yes, the answer is yes.
স্যার
হ্যাঁ, বলো।
বি এর টেম্পারেচার তো তাহলে কমে যাবে বিকজ কাইনেটিক এনার্জি তো বি এর মলিকিউলস এর কমবে বিকজ সেপারেশন ইনক্রিজেস।
Logic would imply yes.
আচ্ছা স্যার।
আচ্ছা, 31.
স্যার 31 বি এর মার্ক স্কিমটা একটু কনফিউজিং, যদি একটু দেখতেন।
Question দেখতেছি। The volume of an ideal gas in cylinder 1.8 into 10 to the power minus 3 meter cube at a pressure of 2.60 10 to the power 5 pascal. Temperature of 297 Kelvin as suggested in figure 2.1. The thermal energy required to raise the temperature by 1 Kelvin of 1 mole of the gas at constant volume is 12.5 joule. The gas is heated at constant volume such that the internal energy of the gas increases by 95 joule. Calculate the amount of gas in mole in the cylinder. এটা তো পারছো।
জি স্যার, এটা আর টু মানে এ টু 1 এর 2 সবই পেরেছি, খালি বি এর মার্ক স্কিমটা কনফিউজিং।
প্রেসার বার হচ্ছে, আচ্ছা এটা আসলে হচ্ছে ইয়া থেকে PV by T equals to constant, ওখান থেকে এটা আসবে। Okay. The gas is now allowed to expand. No thermal energy enters to leave the gas. The gas does 112 joule of work when expanding against the external pressure. So whether the final temperature of the gas is above or below 297 Kelvin. It's very simple. The gas is doing work against the atmosphere, which means energy is gonna be going out from inside the gas into the atmosphere. So the gas is gonna experience some reduction of internal energy, right?
ইয়েস স্যার, ওইটা বুঝেছি, কিন্তু মার্ক স্কিমে মানে ওই এনার্জিটার ভ্যালু কোড করা।
Change in energy or internal energy 120 joules slash 25 joule. Internal energy decreases, so delta is negative. Kinetic the molecule decreases, so temperature lower. আচ্ছা, তোমার কথা হচ্ছে এই দুইটা কোথা থেকে আসলো?
জি স্যার, 120 জুলটা বুঝেছি, বাট 25 জুলটা বুঝছি না।
25 জুলটা হচ্ছে একটা রং আনসার। রং আনসার মানে কি রকম? এক্সাম্পল দ্বারা দেখি। There was considerable confusion of the ideas when answering this part. Some suggested the temperature would rise because the gas had done work. And many answered link was active in delivery quantity of the, but frequently the science of this change were not clear, leading to the conclusion that internal energy would increase. That's how to find 25 টা কোথা থেকে বলতেছি এখানে। This question is telling us that in the entire process of the expansion, the gas was doing 25 joule of work onto the atmosphere. The question is already telling us that. Here we saw that the heat supplied to the system was how much? 95 joule, right? Have a look.
জি জি।
So some students consider that the scenario starting from the beginning, which means before the heat was applied, all the way up to the process of doing the work. As a result, they consider the net amount of energy change would be 95 in, 120 out, so a total of please just a second, I have to take this call. Sorry. So some students thought that this process was some students considered the entire energy consideration from before the heat was supplied all the way up to the point of providing the heat. So they calculated that the total change of energy would be 95 joule in minus 120 joule out. So total 25 joule of heat energy was going out of the system. Some students considered that, whereas some students considered the entire 120 joule was going out. So they considered the scenario, I mean, this part of the work done after the heat was applied. So that's why different students could quote different value of the heat energy that was going out of the system, but both of them were considered to be correct.
But the 120 joule is the more correct answer on here, right?
I would say yes, because the question says that the gas is now allowed. So they say they have used the word now, which means this would imply that now we are talking about the heat going out exclusively.
জি sir.
বুঝে গেছে?
জি।
স্যার
তারপর বলো।
স্যার 31 এর এ তে প্রবলেম ছিল।
বলো এতে কি সমস্যা?
স্যার এর যে 2টা মানে A1 2 আর A2, হ্যাঁ স্যার, রাইজ ইন টেম্পারেচার অফ গ্যাস আর এর পরেরটা
রাইজ ইন টেম্পারেচার অফ গ্যাস বের করার জন্য আমাদের যেটা হিসাব করা লাগবে যে অল টুগেদার Oh, they have already said this, that thermal energy required to raise the temperature by 1 Kelvin of 1 mole of gas at constant volume is 12.5 joule. So basically you have to go for some what can I say, long unitary method. Or if I just tell you the statement, 12.5 joule increases the temperature of 1 mole gas for the volume by 1 Kelvin. Then 111 কত, then 95 joule কতটুকু, 95 জুল এবং হচ্ছে মোল নাম্বার তুমি এখান থেকে মোল নাম্বার চেঞ্জ হবে। বুঝছো কি বলছে?
স্যার মোলের কনসেপ্টটা বুঝিনি।
12.5 joule energy is required to increase the temperature for 1 mole gas at constant volume by 1 Kelvin. এটা হচ্ছে তোমার maths, because you want to input these two variables, find out this one. So this one goes on the right. So এখানে 1 কত হবে সেটা তুমি লিখবা। তারপর হচ্ছে তোমার টোটাল অ্যাপ্লাই করতেছে হচ্ছে 90 জুল, 95 জুল, এবং তোমার টোটাল সিচুয়েশনে টোটাল মোল নাম্বার তো আর 1 না, মোল নাম্বারটা এখান থেকে হিসাব করে বের করছো। অ্যাকচুয়াল মোল নাম্বার কত আসছিল এখানে?
স্যার 0.19 0.189।
আচ্ছা, তাহলে ওই 0.189 এখানে অ্যাপ্লাই করতে হবে। এখান থেকে ইউনিটারি মেথড করে যেটা আসে সেটা হচ্ছে তোমার ডেল্টা কে। বুঝছো?
ইয়েস স্যার।
আচ্ছা, আরটা হচ্ছে এটাতে সমস্যা।
ইয়েস স্যার।
Use the answering part 2 to show that the final pressure of the gas of the cylinder is এত। আচ্ছা, এটা খুব ইজিলি করা যায়। এটা তুমি করতে পারবে হচ্ছে PV/T is a constant, ওই ফর্মুলা দিয়ে ইজিলি করতে পারবা, because we have the same constant number of mole number, we also have the volume is constant, so you can write that P1 V1 by T1 equals to P2 V2 by T2. For this question, V is a constant, so you get rid of the V's, so ultimately your equation is going to look like this. Ultimately your equation is going to look like that P1 V1 by T1 should be equals to P2 V2 by T2. V1 V2 bad, because as per the question the volume was kept constant, so ultimately you are going to left with P1 by T1 equals to P2 by T2. So এখানে তুমি তিনটা ভ্যারিয়েবল বসালে ফাইনাল প্রেসার তুমি ইজিলি বের করে ফেলতে পারবা।
আচ্ছা স্যার,
বুঝে গেছে? আচ্ছা, আমি তো তোমাকে সলিউশন বললাম, নাও ইউ নিড টু থিংক ইন ইওর হেড দ্যাট হাউ ডিড আই কাম টু চুজ দিস ফর্মুলা। ফর্মুলার তো অভাব নাই, হাউ উড ইউ নো হুইচ ফর্মুলা টু ইউজ? দ্যাটস দ্য কোশ্চেন দ্যাট ইউ নিড টু আনসার টু ইয়োরসেলফ। PV equals to
স্যার
1
যে আগে মোল বের করেছি এই কারণে
আগে মোল নাম্বার বের করছে প্লাস হচ্ছে এই পুরো কোশ্চেনে আমাদের কোনো আরএমএস ভেলোসিটি রিলেটেড কোনো ইকুয়েশন নাই। তার মানে হচ্ছে PV equals to 1/3 mc স্কয়ার বা হাফ mc স্কয়ার বা 3/2 kT মেটি ওই ইকুয়েশনের সেটগুলো এখানে অ্যাপ্লিকেবল হবে না। So what you are left with is the basic ideal gas equation, which is PV equals to nRT, or in other words, PV by T equals to K. বুঝছো?
ইয়েস স্যার
বলবেন আজকে আর পড়াবো না।
জি স্যার ঘুম পাইছে স্যার।
আমার দম ফুরাই গেছে। তোমরা
টায়ার্ড লাগতেছে।
বাকিগুলা শেষ করো। থার্মালের ওয়ার্কশিট অনেক বড়, কারণ হচ্ছে প্র্যাকটিক্যালি আমি থার্মালের যে থার্মাল চ্যাপ্টার আমি যতগুলো পার্ট পড়াইছি এটা তোমাদের অ্যাকচুয়াল সিলেবাসে আছে 3টা না 3.5টা চ্যাপ্টারে মনে হয় কভার করা, মানে 3টা বড় চ্যাপ্টার একটা ছোট চ্যাপ্টার, ওই জন্য থার্মালের ওয়ার্কশিট বিরাট। Plus, you can see over here that one of the things that I needed to convince you that all of these worksheets were covered for the same number of same duration of years. So the worksheets which you see that those are bigger in volume, essentially it means that a chapter থেকে question বেশি মার্কের হয়. That's a general statement. So if you see some chapter has a worksheet that is, let's say, 100 pages, you have to understand that chapter is wow. If you see some chapters are only, let's say, 20 pages, that chapter is okay.
Sir, are there chapters with 100 pages?
I hoped someone would ask.
Oh dear.
Oh my God, no. Sorry, I have to print them.
Electromagnetism is 70 pages.
Oh no.
At least there is none with.
আপনি কোচিং এ আছেন, তাহলে আমি এসে নিয়ে যাব।
আচ্ছা ঠিক আছে, আমি তো কালকে সকালে চলে যেতেছি, আমি মামুনকে সব প্রিন্ট করে দিয়ে রাখতে বলবো। আচ্ছা ঠিক আছে, তোমার প্রিন্টস এর আমি আলাদা করে রাখতেছি। বলবান তোমরা কারা কারা লালমাটিতে থাকো একটু আমাকে একটু মেসেজে নক দিও, তাহলে তোমাদের সেটগুলো আমি আগে রেডি করে ইনভলভ ভরে রাখতে বলবো। Or I should not be doing this because that would be a sort of a discrepancy. Anyway, I did not say this. Forget about it. Allah Hafiz. Good night.
হ্যাঁ, তার মানে দিবেন না?
পরে আলাপ করতেছি এগুলো। সাজিদ এগুলো নিয়ে আমার সাথে পার্সোনালি কথা বলো, পাবলিকলি কথা বলার এগুলো নিয়ে ঠিক না।
ওকে ওকে ওকে।